Hello, students of class 9, Advanced Maths, Plane Geometry. Exercise 7, Plane Geometry, Plane Geometry, Plane Geometry, Exercise 7. See question number 2. In an isosceles triangle ABC, the equal side AB and CA. See, this is an isosceles triangle. Isosceles triangle. A, B, C. Equal sides. These two sides are equal. BA and CA are produced to A up to E and F. BA, it is produced to E, and CA, it is produced to F. Such that AE is equal to AF. Such that AE equal to AF. This is equal to this. If K and L are the midpoint of FB and EC. This is FB and EC. If K and L are the midpoints of FB, this K and this L are the midpoints. Prove that FB is equal to EC and AK is equal to AL. See the question. Here the question is. See the question. See the question. In an isosceles triangle ABC, the equal sides BA and CA are produced through A up to E and F respectively, such that AE is equal to AF. If K and L are the midpoints of FB and EC, prove that FB is equal to EC and AK is equal to AL. Now see how I'm going to prove it. It is given ABC is an isosceles triangle. ABC is an isosceles triangle, and AE is equal to AF, and midpoint of FK is equal to KB, and EL is equal to LC. FK is equal to KB, since K is the midpoint. EL is equal to LC, since L is the midpoint. To prove that FB is equal to EC and AK is equal to AL. Now see how I'm going to prove it. Now the proof. In triangle ABF and triangle ACF, ACE, not ACF, ACE. ABF and ACE, ABF, ACE. These two are the triangles. Here you see AB is equal to AC. This is given. Again, AF is equal to AE. This is also given. And angle BAF is equal to angle CAE VOA. Therefore, triangle ABF, is congruent to triangle ACE from SAS congruency. Therefore, BF is equal to CE, CP CT. Now, again you will see that here you will see BF. Now, BF is equal, instead of BF, I can write 2FK is equal to 2EL. Why? Why I can write this? Since K and L are the midpoints of, they are the midpoints of BF and CE, since they are the midpoints of BF and CE. Now, therefore, FK is equal to EL. FK is equal to EL. Now, again, in triangle A, at the same time here, at the same time, I can write angle BFA is equal to angle CEA, CP, CT. Since these two triangles are congruent, therefore this angle is equal to this angle CPCT. Now, in triangle AFK and triangle AEL, see, AF is equal to AE, this is given, and BFA is equal to angle CE, BFA is equal to CEA, BFA is equal to CEA. This is already proved. And FK is equal to EL. This is also proved. So, therefore, triangle AFK is congruent to triangle AEL. AFK is congruent to triangle. AFK is congruent to triangle AEL from SA as AFK is congruent to AEL SAS. Therefore, your AK is equal to AL CP CT. Proved. Now, this is question number. This is question number. Sorry, I have not written the question number. This is question number 2. And it has been proved for you. Now, I am going to another question. That is question number. Going to another question. That is question number 3. See, question number 3. Question number 3. This is 3 question. See the question. In triangle YXZ, this is the triangle. This is the triangle. This is the triangle. XYZ. This is the triangle. See, in triangle XYZ, the bisector of angle Y and angle Z intersect at point O. Bisector of Y and Z intersect at O. Prove that YOZ is equal to 90 degree plus half angle X. So it is given in triangle XYZ, the bisector of angle Y and angle Z meet at O. to prove that angle YOZ is equal to 90 degree plus half angle X. Now see proof. In triangle XYZ, angle X plus angle Y plus angle Z is equal to 180 degrees. This you all know. Sum of the angles of a triangle is 180 degree. This all you know. Now I am going to divide it both side by. Now I am going to divide it both side by 2. Both side by 2. I'm going to angle X plus angle Y plus angle Z by 2 is equal to 180 divided by 2. This is 90 degree. So that angle X by 2 plus angle Y by 2 Z by 2 is equal to 90 degree. Equation 1. So now in triangle YOZ, angle OYZ plus angle YOZ plus angle OZY is equal to 180 degree. Now instead of OYZ I can write that is angle Y by 2, because OY is the bisector of angle Y, plus angle YOZ, and instead of OZY I can write Z by 2. Angle Z by 2 is equal to 180 degree. Now see, from equation 1 I get what? Angle Y by 2 plus angle Z by 2 is equal to 90 degree minus angle X by 2. This is equation 2. From equation 1 I get this. Now I am going to put the value of angle Y by 2 plus angle Z by 2 in this equation. I'm going to put the value of this in this equation. So this equation becomes 90 degree minus angle X by 2 plus angle YOZ is equal to 180 degree. Therefore angle YOZ, this will be equal to 180 degree minus 90 minus plus angle X by 2. So angle YOZ will be 90 degree plus angle X by 2. This is proved. In an isosceles triangle AB equal to AC, the bisector of angle B and C meet the opposite side at D and E respectively. Prove that DE is parallel to BC. Question number 5C. In triangle, this is the triangle ABC, the bisectors of angle B and C, they meet the opposite side here at D, and see, this meets at E. Now we have to prove that DE is parallel to BC. DE is parallel to BC. This is E. This is your E. So it is given that ABC is an isosceles triangle. ABC is an isosceles triangle, and AB equal to AC, it is given to you, and BD and CE are the bisectors of angle B and angle C. BD is the bisector of angle B and CE is the bisector of angle C. To prove that DE is parallel to, you have to prove that DE is parallel to BC. So how I am going to prove it, you will see it. You will say proof. In triangle ABC, BD is the bisector of angle B. BD is the bisector of angle B. So therefore, AB, or you can say, it is better to say, instead of AB, it is better to say, therefore, BA by BC is equal to AD by CD. BA by BC is equal to AD by CD. This is the theorem. This theorem is not in your book. This theorem is in class 10. This theorem is in class 10. I will show you the theorem. See, the internal bisector of the vertical angle of a triangle divides its base in the ratio of the other two sides. This is the internal bisector, of a vertical angle of a triangle divides its base in the ratio of the other two sides. This theorem is in class 10. The internal bisector of a vertical angle of a triangle divides its base in the ratio of the other, this is O, other two sides. This is equation 1. Now again you will see that that is since CE is the bisector of angle C, therefore I can write that CA by CB is equal to AE by BE. The same theorem. These two are the same theorem. This is equation 2. Now what I am going to do is I am going to divide these two. 1 divided by 2. So BA by BC divided by CA by CB, that is equal to AD by CD divided by AE by BE. This CB and BC, they are the same. So BA by BC instead of CB I can write BC by CA, this is equal to AD by CD into BE by AE. See, BC cancels out, this and this cancels out, and now what is BA is equal to CA? BA means AB. See, BA is equal to CA. this is BC, this BC and this BC, this cancels out, this cancels out. Now see, BA and CA, they are equal. BA and CA, they are equal, it is given. So this also cancels out, this also cancels out, and it is 1. So AD by CD into BE by AE. Now see, what I am going to do is, now this whole I am bringing here to the, this whole I am bringing to the left side. So therefore, AE by BE is equal to AD by CD. So AE by BE, AE by BE is equal to AD by CD. CD or DC, they are both are the same. Now, therefore, ED is parallel to BC. So how ED is parallel to BC? Again, there is a theorem in the general book of class 10. There is a theorem in the general book of class 10 in the chapter triangles. It is given in the triangles. This is in your general book class 10. See, class 10. This is that theorem, is the theorem here. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Oh, no, not this, not, sorry, this is not, this is the converse of this, see. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. See, it is divided in the same ratio. AE by BE is equal to AD by CD. They are divided in the same ratio. Therefore, this is parallel to this. So I can write here, this is the theorem which is in class 10. If a line divides, I can write it here. This is if a line divides any two sides of a triangle, in the same ratio, then the lines is parallel to the third side. So this is, if a line divides any two sides of a triangle in the same ratio, the line is parallel to the third side. This is in your class 10 general maths. This is in your class 10 general maths. So this is over your question. This 5, it is proved. Now I am going to question number 6. Question number 6. If the bisector of an angle of a triangle also bisects the opposite side, then prove that the triangle is isosceles. Means question number 6. If the bisectors of an angle of a triangle, of a triangle ABC, if the bisector of an angle, suppose this is the angle, bisector of an angle also bisects the opposite sides, means this is equal to this, then we have to prove that ABC is an isosceles triangle. Given, what is given? It is given that in triangle ABC, AD is the bisector of angle A. AD is the bisector of angle A. Given in triangle ABC, AD is the bisector of angle A, and BD is equal to DC. You have to prove that. Triangle ABC is an isosceles triangle. So see how I'm going to prove it. Since AD is the bisector of angle A, therefore AB by AC is equal to BD by DC. This is again from the theorem I have already told you earlier. This is the theorem from class 10 advanced maths. This is the theorem. This theorem is in your class 10 advanced math. In your class 10 advanced math, the internal bisector of the vertical angle of a triangle divides its base in the ratio of the other two sides. So this is the internal bisector. It divides the other two sides in the ratio of the, it divides the base, sorry. This bisector, this is the bisector, of a triangle divides its base, this base, in the ratio of the other two sides. Divides the base means divides the base in the ratio of the other two sides. That means AB by AC is equal to BD by DC. You have to prove. So this is the theorem which is in your class 10 advanced maths. This is the theorem in your class 10 advanced maths. So this is now, since BD is equal to DC, therefore BD DC cancels out, and therefore I can write AB by AC equal to 1. Therefore AB equal to AC. Therefore ABC is an isosceles triangle. Now this is proved. 8. Question number 8. If the median of a triangle are equal, prove that a triangle is equilateral. Question number 8. That is, if the medians of the triangle are equal, medians A, B, C, the medians B, E, A, D, C, F, the medians are equal, then we have to prove that this is an equilateral triangle. Given in triangle ABC, the medians in triangle ABC, the medians AD, BE, and CF are equal. Therefore, we have to prove that. To prove that ABC is an equilateral triangle. This we have to prove is an equilateral triangle. Proof. The point of intersection of the three medians, this point of intersection of the three medians, this is I represent as G. The point of intersection of three medians, 1 minute, the point of intersection of three medians, the point of intersection of three medians, it is called as centroid. The point of intersection of three medium, it is called as centroid. This is centroid. So here G is the centroid of the triangle. Now here G, it is the centroid of the triangle. So this centroid divides the median in the ratio 2:1. This median, this not median, this centroid. The centroid divides the median in the ratio 2:1. This centroid G, the centroid G. Since G is the is the centroid, since G is the centroid of the triangle, since G is the centroid of the triangle, therefore AG is to GD is equal to 2:1. Or I can say AG is to AD is equal to 2:3. Or I can say AG is to AD, AG is to AD. This whole I can say 2:3. So AG. So now I can write this as AG is equal to 2/3 AD. This is equation 1. Similarly, I can write BG is equal to 2/3. Similarly, I can write BG is equal to 2/3 BE. This is equation 2. And again, similarly, I can write CG is equal to 2/3 CF. This is equation 3. This is equation 3. Now, what do we find here? You see. Now, now what do you find here? So now you see. You see. Similarly, again, similarly. From this, first of all, I conclude this from 1 2, and 3, I can conclude that AG is equal to BG is equal to CG. Why? Since AD is equal to BE is equal to CF. This is given. This is given to you. This is given. Since the medians are equal, this is given to you. Therefore, this is equal. Now again, I can write again GF by CF, that is equal to 1/3. I can write, because this is 1 and this is 2. 2:1 ratio. I can write this. So GF is equal to 1/3 CF. This is equation 4. Similarly, I can write, see, GE by BE is equal to 1/3. Therefore, GE is equal to 1/3. Now see, GE is equal to 1/3 BE. So from 4 and 5, GF is equal to GE. Why? Since CF is equal to BE. The medians are equal. This is given. So what I got here that BG is equal to CG and GF is equal to G. I got this. So now, the last part of this proof, this is the last part of this proof. I'm going to the last part of this proof. This is now in triangle BGF and triangle CG and triangle CGE. This two. See, BG is equal to CG. We have proved this. I have shown you in this way. Proved. Again, FG is equal to EG. This is also proved. I have shown you. This is proved. And angle BGF is equal to angle CGE. This is VOA. So therefore, triangle BGF is congruent to triangle CGE. that is SAS, congruent. Therefore, I can say BF is equal to CE, CP, CT. Again, since F is the midpoint, so twice BF and E is the midpoint is equal to twice CE. So I can write, therefore, AB equal to AC. This I can write. Now, similarly, I can say, similarly, I can say that AC is equal to BC. We have to prove it. The procedure will be the same procedure. So I can say that AC, what is AC is equal to AC, your AC will be equal to BC. For AC equal to BC, you have to select AC is equal to BC. You have to select these two triangles. You have to select for making. That means all I can. Let me take. Similarly, we can prove. Similarly, we can prove. Similarly, your triangle AGE is congruent to triangle BGD from SAS. So your AE will be equal to BD CPCT, and since E and since E and D are the midpoints, so twice AE will be equal to twice BD. So AC will be equal to BC. From these two statements, I can conclude that. Therefore, AB equal to AC equal to BC. Therefore, ABC is an equilateral. ABC is an equilateral. ABC is an equilateral triangle.